Welcome to this Unreal Engine training webinar. We are excited to share our latest developments in this area with you. I'm Heiko Wenzel, the Director of Industry Management at Epic Games. With me here, I have Alban Bergeret, our Solution Architect for Training and Simulation, and Doug Wolf, our Business Development Manager for Manufacturing Industries. Let me give you a short introduction to Epic Games and Unreal Engine, and dive into our engagements in training platforms built on Unreal Engine, and then hand it over to Alban with the current status on our developments in this area and how to get your work started. I think we have some exciting updates here for you. The last 2 years were a power driver for change and innovation in the technology sector. Aspects like cloud computing that were previously defined as impossible found their way into production in several industries. AI, automation, and machine learning, as well as virtual collaboration, have driven new work philosophies, especially with real-time tools and game engines. And interactive, immersive experiences have gained major attention, especially in the training and education sector. So let's take a deeper look into some of the learnings here. The world of information and data has become incredibly rich through the simplification of 3D data creation. We live in a 3D world, and interacting with 3D objects is natural to us. Working with XR has opened new opportunities for education, training, and simulation like never before. Studies show that skill training in immersive environments is not only a safety benefit, but provides a higher retention rate and engagement with the content. Of course, the better the content, the better the experience, and that is where game engines get interesting. A lot of optimization principles have reached their limit, and it needs bigger changes in the approach of changing workflows within the concept of Industry 4.0 targets. Real-time, collaboration, digital training, and remote support are trends this year that can be addressed by looking at game philosophies and engines. One of the key focus points here is the integration into HMI workflows, as they touch so many of the design decisions and the future value of our products. The interaction with machines, designing the interfaces, and teaching the machines themselves will define our future workforce and need development platforms that know how to produce efficiently in real time to meet the demand of current go-to-market strategies as well as sustainability. Real-time technology is rapidly becoming a part of various industry verticals, and the content creation for these new experiences drive job definitions and need visual artists and educators to support. The job opportunities for skilled real-time artists are constantly increasing, and we are working on a partnership program to support this growing market. Epic Games has a unique position as a publisher, creator, and software developer in the entertainment and manufacturing industry. At the heart of our engagement sits Unreal Engine that allows us to create our own games like Fortnite, but also enable other game developers to produce their own amazing content and games. With Epic Online Services making complex services available to every developer, the engine and connected libraries have changed the development and creative landscape. And over the last years, the use of Unreal Engine in the non-gaming industries has gained a lot of traction and success with benchmarking use cases. Fortnite as a social platform has allowed us to create some amazing technology that has its benefits across all of our engagements. Cross-platform use cases with tremendous amount of users and constant updates are not only a gaming achievement, but have key benefits for all our industry partners. Especially in the last years, with all the restrictions and changes we have seen, great adoption in various workflows and have driven changes across different industry verticals. The amount of developers and players in this platform represents a unique opportunity for brands and cross-platform IPs. What brings game engines into the training, education, and simulation area? Training and games have a lot in common. Every game has a very basic procedure at its start to teach how to behave and be successful in a new situation with very specific skill sets and interactions. Sounds pretty much like every other education or training problem proposition. What games have had to master on top of that is to make that onboarding fast and create an appetite to come back and do more. That is where we can do better on the industry side. The work experience of the future will be defined by gaming principles and more fun process definitions. I have mentioned industry verticals, and I would like to give you an overview on what we are developing for. The core of our industry engagements lie with media and entertainment, where we have seen a great change happen through virtual production and the rise of LED production stages for visual effects. AEC has been a great place for democratizing the creation of visual experiences, pre-visualization, as well as digital twins. On the simulation side, the game engines have become a key player in training AIs or enhancing machine learning principles. And finally, my personal focus point, the automotive industry, has found adoption opportunities across most workflows and departments. It is truly exciting to see how real-time development is providing benefits wherever you look. Our mission with our developer community is found in being part of the overall creative ecosystem. We use our own tools to develop solutions for our games as well as industry partners under the premise of maximum visual fidelity and technology development. In the latter case, we do not work as a service but only as a support operation. This way, we make sure that if we understand how to succeed, our engine users can succeed as well, and we can all share our developments in an open and connected platform, which eventually will lead to building world-class educational experiences based on Unreal Engine as a development platform. We are seeing a shift in the educational world towards using real-time tools more, as well as making real-time tools and especially game engines part of various curriculums. Currently, the industry is ahead of the educational system, and we are offering various online and in-person ways to catch up with skills and knowledge, but there is a frantic need for experts in the market, and we have to figure out how to bring them to the skill level where they need to be. Building training and analytical real-time environments is a key for skill training, but also for AI training and machine learning. And starting to think about what libraries you can use to build those systems is a key aspect of this presentation. In this, synthetic environments have become a cornerstone for the development of AI-based applications in autonomous vehicles and robotics. Mixed reality applications are becoming key in various design development workflows and are sure to change the interaction between humans and machines. Having access to libraries to create these environments is a key focus for our platform approaches and amplify go-to-market efforts for our clients. Real-time, collaboration, digital training, and remote support are trends this year that can be addressed by looking at game philosophies and engines that provide massive libraries. One of the key focus points here is the integration of these libraries and creative software as a service production tools into the thought process and production. With tools like the MetaHuman Creator, Megascans, and Sketchfab, the possibilities in content creation for smaller teams become unlimited. The creation of massive open world environments become a fun workflow when you have access to Megascans and you can build and change on the fly without the need to model and capture everything yourself. Even more so if you think about the creation of digital humans. The Quixel ecosystem is a great way to enhance and speed up the development of experiences and gives any creative a high-quality shortcut to object materials and scenes that will make every project shine. The availability of libraries like this, as well as the capability to add content through reality capture, have changed the landscape from a few highly skilled to a wide mass of artists and creatives being able to produce awesome content. The easier it is to produce the 3D worlds, the more time can be spent on developing the experience, and the higher the value of the outcome, especially in training. This is especially true for 3D objects and a platform that allows the aggregation and sharing of millions of assets like Sketchfab. A great benefit on top of that is the connectivity of this platform and the capability to add touchpoints to your user journey depending on what cloud or hardware is available for access to your project. As stated before, the shift towards cloud-based services and experiences is speeding up, and being able to deploy experience through on-demand WebGL or pixel streaming means with added code presence and social interactions, will need platforms that offer these connections with little or no development effort. Digital humans have become a discussion topic for a while. The creation of hero game characters has been a difficult and specialized task, taking months to realize with complex workflows. What if that effort can be reduced down to minutes or hours? MetaHuman Creator is a cloud-streamed app that takes real-time digital human creation from weeks or even months to less than an hour, at an unprecedented standard of quality, fidelity, and realism on top of that. When your character is finished, you can export and download it, rig it, and get it ready to animate it in Unreal Engine. For film, game, and simulation productions, this is an absolute game changer. For us, it was important to understand what is needed to offer the right toolset to contribute to this area, where real-time needs meet accuracy as well as visual fidelity requirements. Game engines have a lot to offer, and the breadth of client projects and successes that we've seen in this field is really impressive, across all the industries that we're covering with our engine. A nice plus is Fortnite Creative on top of this. There is a unique angle to this world where social gaming platforms can meet education and produce experiences that engage at a massive scale like never seen before. The toolset makes it easy to focus on the content and experience, and everything else that you need to reach millions is already set up for you. A great example of that was like this example that you see here, where you can learn about history in a very interesting and new way. Unreal Engine offers a very pragmatic approach to working in the training and simulation field. The framework is ready to build any experience you can imagine, whether it is with or without XR. Epic Online Services offer more and more of the needed infrastructure tools to handle the social interactions. What we can focus on now and what we have seen through the mega grants are special features that are being developed with open source principles in mind. And that leaves it to working on the curriculums and integrations into current workflows. With that, I would like to hand it over to Alban and dive deeper into the toolset and options you have for working in Unreal in this segment.
Thank you, Heiko, and thank you everyone for attending. As a training and simulation engineer, I'm really happy to be part of this webinar today, where we will talk about training. We choose this title, Simulation Workflows for Training Application, because the workflow we are using in the simulation industry for many years actually applies to anyone who wants to offer a training. And that will be the red wire of this presentation, the workflow. Let's start by an academic definition. If you look at Wikipedia, simulation is defined as an imitation of the operation of a real-world process or system over time. When we are training on a process or on a system. So virtual training really needs simulation. But first, why virtual training? We go virtual when a training operation is too dangerous, too expensive, or also when the training material is hardly available. For instance, you need a vehicle or a military fighter. We can also go virtual when we must train on unexpected conditions, which are really complex to meet in the reality. Also, when we need some real experts in one particular field to be there to train people. And most of the time, it's because we need to train anytime and anywhere. And as a bonus, some studies have proven that it can be more efficient than traditional training methods. Before going into the details of this workflow, I wanted to start my presentation with an illustration, a customer case from the Red 6 company. Listen carefully to this video because you will notice that these guys perfectly explain why it's sometimes needed or mandatory to go with virtual. So let's listen to it and talk to you soon.
Red 6 is an augmented reality platform company. We build solutions that enable things that are impossible using augmented reality.
We're currently focused on our shortest term goals, which are getting our solutions into fighter pilot cockpits, basically enabling the fighter pilots to be able to see entities that don't exist and fight and train against them.
Every time a fighter pilot goes up to fly and train, they need someone to fly and train against, and that's a multi-billion-dollar a year problem. We don't have the airplanes, we don't have the money, we don't have the pilots, and even if we did, we're not capable of simulating modern near-peer threats.
And then you add in any of the actual risk factors or the human lives into it, and it becomes a math problem that doesn't look so great for you.
What we've done with the augmented reality is seek to replace the need to put the adversary aircraft and all of the associated costs up in the sky. We can do that through augmented reality and using Unreal to simulate any threat we want in the world, and that's a tremendously exciting value proposition.
We've talked to a number of different pilots about this, both Air Force and Navy and many others. They're curious but skeptical because they think, how's this going to work? Because they've used head-up displays for multiple decades now, but are extremely narrow, one color, sometimes only one eye.
We're asking the technology to do a lot of things. First, we need to track and understand what the airplanes do and what the pilot's head is and what the pilot is looking at in the most dynamic environments. 300 to 400 miles an hour, pulling 9Gs, doing aerobatics. We need to then draw really quickly to a display technology that's capable of working outdoors in bright environments across a network. And we're saying, oh, by the way, we need to do that sub 20 milliseconds for it to be training value. So there's a massive amount of technical hurdles that we've had to overcome. But I'm delighted to say that we've done it, and it is working spectacularly well. And the Unreal Engine has been a huge part of that.
Doing augmented reality correctly requires extremely low latency.
When you're on the ground and you're doing something in augmented reality, there's kind of an almost like fudged error that doesn't exist in the air. So now we're doing 300 miles an hour plus, and any of those discrepancies or deviations show themselves in quarter-mile distances.
So anything that you can do to shrink this latency stack has a massive impact on the realism and therefore the training value. Did we start with Unreal Engine? No, we didn't. But we moved to it as soon as we could.
We saw about a third of the original latency that we had from our previous solution. After that, it was no questions asked. This is how we're going to build this tool.
The biggest challenge we're trying to display synthetic assets is tracking. Without tracking, it doesn't matter how good your augmented reality display is because it's going to be dancing all over the place.
They can go up, down, left, right, do barrel rolls, do backflips, whatever. So how do you figure out where that head is now? Not necessarily where the aircraft is, but where is that pilot or where is that co-pilot looking?
So we had to invent a totally new method of tracking, that we track the head in relative terms and we track the aircraft in absolute terms. You put those two together, you bind the camera to it in UE4, and you have a 300 miles per hour augmented reality solution that you can use, and that's exactly what we built.
The reactions we've been getting from pilots, they've just been incredible.
The first time you're up in a real airplane and you look out of the window and there's a big old airplane flying around in the sky that doesn't actually exist. And the penny drops in that they start to understand the real training value.
They get out and they go, where the heck has this been? We want it now. Why can't this be in my cockpit tomorrow?
Red 6 today is a video game in the sky, focused on the Department of Defense. But looking beyond that, that's where the real excitement comes from, because we're building the future in all fields, military and civilian.
It's always great to see such projects, such achievement, but what was the work behind it? What are the steps to define a virtual training? I have a bad news. In fact, actually, there is no single answer to this question. That's up to you to define your own curriculum. The first step, and probably the most important one, is to gather your requirements. You have to start by asking a lot of questions that can fall into 4 different buckets: message, audience, medium, and assessment. For instance, what do you want for your trainee? to learn a process, to discover a new environment, to exercise emergency procedure. For your audience, will your trainee be beginner, expert, motivated or reluctant, young or old? Do they know well the technology? Have they already some skills? And how do you want to deploy this application? Would it be a standalone training or with an instructor? Would it be single or networking collaboration on a screen, on a virtual reality headset or any kind of device? And how do you want to measure the results of the training? Do you want them? Do you want to get raw data or analyze this data? And do you want also to store this data? And have you the right to store this data? And do you want to track the evolution over time? A lot of questions. And it's really important to know what you want to do before starting to think on anything. Whatever the answer to the previous question and whatever your industry, you will always face a similar workflow that we have in simulation. You will first need to create a content where your simulation will take place, and then create your scenario to run your actual behavior of this simulation, and at the end, do some analysis. For creating your content, you will probably have to create an environment, a facility, or the hospital, or the terrain we are running on. And then you need to create some 3D models to bring some life in this environment, and also probably the particular material you want to train on. Then, on the scenario part of things, you need to create interaction. You can have just animation, but also interaction which are reacting to what the trainee is doing. Then this scenario is deployed and run to different devices, probably connected to some hardware or multiple visualization channels. And at the end of this session, you need to collect results and review the simulation of the training session you did. Don't be afraid with this slide. It's a lot of content, but it's not meant to be read. The goal is to illustrate that with Unreal Engine, we already provide a lot of tools to help in creating all these application steps. And these tools can be sorted into different buckets. For creating your environment of model, we have creation tool, libraries of existing content, streaming services. For creating your scenario, you can prepare, run your scenario, and even connect with external third-party simulation or process. For deploying, we have a deployment architecture that enables you to run your application on different platforms and on different kind of displays. And when it's time to analyze, you can do several kind of export, data or multimedia export. So we will make some specific focus for the most important tools from this list. But most important or very important thing is that each tool needs to be consistent. The global suite of tools needs to be consistent. And the notion of platform is really important there. I'm coming back to this pyramid that Heiko introduced before because it's really important for us. Actually, there is no one-size-fits-all application in training. Is Unreal a training tool? No, it isn't. Unreal is a software development platform that will enable you to create your training application. And this platform will save you a huge amount of time because the most challenging or technically difficult feature that you need have already been developed by us or by third party. So your work will be limited to just this top part of the pyramid, meaning that you have to glue this component together and adapt them to your curriculum to have your final application. You don't have to start from scratch. There are probably some existing tools or content available in the platform or through third-party partners. Let's see some of them. If we have to think about creating environment and models, there are pipelines tools to create your terrain based on geospatial data or manually created. You can also import data models from modeling tools or from your CAD drawings tools. And if you don't have this model, you can just get some pre-existing libraries. Some models are paid, but currently we can find a lot of free content. Let's see what is available to grab some content. With Unreal, you have access to our Unreal Engine marketplace that contains a lot of assets, 3D models, sometimes already animated, rigged, but you can also find some code plugins to connect to additional web server or devices or do some specific stuff. When you are using Unreal, you also get access to the whole database of Quixel Megascan assets. It's wonderfully nice assets that you can import and use for free in Unreal. You can also find useful resources on ArtStation, not only data and models, but also people that you can hire on your project. You can find model on Sketchfab, do some creation using photogrammetry by reality capture, and you can even find some blueprints example in a website called Blueprint UI. And of course, if you need to deal with characters, you have the MetaHumans that you can customize to your own needs. 3D formats for assets has always been a challenge. There are a lot of formats around there, each one having its pros and cons. Our philosophy here is not to dictate any standard or privilege one over the other. Our philosophy is more to be format agnostic and to be able to digest any kind of various format. That's why we created the Datasmith module. Datasmith module is an import workflow that connects to any of your tool, and especially in the manufacturing industry, CAD tools. And this tool enables you to inject your data, but not only get it to Unreal, also adapt it to real-time 3D rendering. We have a concept of visual data prep, which is a way of defining processing recipes for your model, and then when imported, your model will be textured, LODs for real-time animation will be created, and all the boring stuff that needs specific skills to make them optimal is handled by this model. We also support widely established format like FBX, USD, and GLTF. And if you need to import and update your format, we can even script that import workflow with Python. So even if you are working actively on a model, it can be put up to date really quickly in Unreal to its latest version. Now that your world is set, it's time to make it look nice and realistic and moreover interactive. So then we switch to the experience definition and execution tools. You can set up your lighting condition, the weather, the environment, the wind, whatever, and then start to add some interaction to your objects. Interaction on objects are a way to gather user input and make the object react to this user input. In the past, it was mandatory or recommended to be, let's say, a software engineer or developer to create this kind of interactivity. But nowadays, it's possible to use in Unreal what we call the Blueprint Visual Scripting System. It's, like the name implies, a system that creates interactivity by just linking together some building blocks. You can react to any event, being a trainee input event or an event triggered by any object in your scene, or collision or interaction or click of mouse, and then use these building blocks to react to that and move your object, display some text, and whatever you can imagine. The system doesn't require any line of code. It's perfect for designer and content designer. It also enables you to do really fast prototyping. And honestly, it has very good performance when it comes to scaling. Sometimes you need to be more close to the system or have very advanced purpose or advanced feature, or sometimes just create new building blocks that don't exist. In that case, you can rely on a software programmer to quickly create some C++ feature, and this feature gets exposed to the blueprint system mentioned above. And then you can really quickly extend the engine and the platform to customize it to your needs. Now that your application is ready, it's time to run it, to deploy it. And for this particular part, we support a lot of different hardware. Your application can be hosted on the cloud, running locally on a computer or a mobile device. And with each device, you can select a quality level or performance level to always have the best compromise between what the device supports and what you want to display. You can display on single screen, huge projection system, and connect to any kind of external peripherals. So let's see that in detail. What is really interesting in Unreal is that you create your application once and you deploy it manually. We have a publication steps. That means when you are inside the editor and you have everything working well, you can decide to package and public your application to a specific target. In this step, your assets will be processed, sometimes optimized for this specific target. Your code logic will be compiled to this specific target, and it's done just in one single click. So the same application can be run on a PC, on a Mac, on a mobile, or on any kind of HMD, head-mounted display VR reality devices. It's really important to understand that the augmented reality is really a trend we see these days, and it's becoming more and more common. The device prices have lowered a lot, but there are so many hardware devices that in the past, each developer had to implement a custom support for them. And at the end of the day, the combination of engine versus devices gets really crazy. And if you look at the number of connections on this drawing, you see it can scale very, very well. So we had a need for standard. And then the Khronos Group, which is a member-driven consortium that manage open standard, decided to go and unify this way using OpenXR. OpenXR is an application interface to unify all interface for all runtime. So when you are inside a game engine, you target your application to OpenXR, and then each device manufacturer will have its own driver support for OpenXR, and then your same application will be able to run on any device just by switching the driver at runtime. And it's a huge time saver because you can design your application in a generic way and have it working everywhere. In order to support this new paradigm, we created a lot of templates and examples which are really new and are really state-of-the-art implementation. You can find on our website or in the Learn tab of our Unreal Engine launcher some great examples for VR reality, virtual reality experience, augmented reality on HoloLens or on other devices, mobile devices, and also some collaborative applications where you can put different people in network and share the same experience. Another trend we see often these days is running an Unreal-based application on the clouds. Not only it enables you to have access to more computing power that you can do in a desktop application, but it also enables you through our pixel streaming algorithm to run 3D interactive application on mobiles or devices that don't have the full computing power that you can have on a PC. So with that technology, anybody can train anywhere and at any time, you're still using the 3D real-time interactive technology. We support a major cloud service provider and provide some how-to guides to help you in this deployment task, along with some technologies to make it easier to deploy image to virtual machine like containers and stuff like that. For specific application, just running on a mobile device or a screen is not sufficient, even with an HMD headset. You need to go bigger to be more immersive. And in that case, computing power from a single computer is not sufficient. You need to run multiple channels to cover a large area. And we support that particular use case, being able to run clusters of PC running Unreal and doing all the blending and warping stuff needed to display on very large immersive system. This technology called NDisplay is used a lot in the simulation industry and also in the movie and entertainment. It's the base technology that enables us to display LED walls, the famous technology that has been used in the Mandalorian TV show. When the training session is over, it's always good to have an after-action review session with the trainee to discuss about what was good, what was wrong. In order to make this session more efficient, it's really interesting to keep a trace of everything that occurred during this session. It can be some screenshots, some movies, recording, or even the full session that you can replay and jump at any time. It's also really useful to keep some analytical data that you cannot see in real life. Like for instance, how many times did this guy took to do this procedure, or where was he aiming at during this action? Did he skip some important part of the process? And then this data can be used to produce reports and sometimes get qualificative reports. I don't know if we say that in English, but just a confirmation of his skill to enable him to work again on this particular process. This is a really important part of the process, and the fact that you are inside software to measure and exploit all that stuff and sometimes directly feed the learning management system is really interesting in the training space. Well, I'm done with my part, so thank you for your attention, and now I will hand over to Doug, who will show you some additional examples. Thanks everyone, and Doug, the floor is yours.
Thanks, Alvin. Hi everybody, I'm Doug, and I'm here to talk about specific examples where companies have taken Unreal Engine and used it to create training scenarios. So I think it's important to note, and something that Heiko and Alvin have alluded to earlier, is that Unreal Engine is a toolbox. It's full of components that allow you to build ideal training scenarios. So for example, you can import data through Datasmith, and that allows you to take almost any type of data format and bring it into your Unreal Engine level. Rendering is a huge part of Unreal Engine. We have all these sort of pretty pictures that we share all the time of photorealistic rendering modes, but also you can do non-photorealistic rendering for rainbow CAD images or schematic diagrams. As a game engine, we are loaded with interaction models. So, mouse and keyboard are very standard and game controller, but there's touch interfaces, all the interaction models for haptic or AR, VR, plus all the different ways you can set up camera controls, third person, first person. You can have observer cameras. There's a whole slew of ways to interact in the environment when you're doing your training that can support your training applications. You have VR and AR support. So the idea there is that, any type of HMD pretty much works with Unreal Engine. We have support for all the consumer grade ones and all the enterprise grade ones as well. So, you can conduct training in VR, but crucially, from the same training application, you can easily make a normal screen kind of training application. You can mix and match the different people. And the way you mix and match different people being trained is through the multiplayer layer, which is intrinsic to a video game software. Most games have some element of multiplayer, and it's a core function of Unreal Engine. So that means you can bring in multiple trainees to train at once. You can train different job roles in a scenario. You can have a trainer in there. You can have observers in there. And that all allows you to build a training program that can literally be accessed from anywhere in the world. I think one feature that kind of gets undersold sometimes is the AI. Being able to put light AI components into a training scenario is absolutely crucial. You can, use traffic, pedestrians, animals, whatever you need to enrich and add randomness to the training scenario. And those can be put in with a few clicks, literally in Unreal Engine in a lot of cases. But I think the core principle that aligns with training is the idea that since Unreal Engine has been designed to make games, we can throw together levels of world building, but also scenarios, behaviors, etc., really, really quickly, because that's what games are made of. Be able to create levels quickly is an important part of any game engine, and specifically Unreal. So it's very easy to sort of build out different training scenarios, tweak them, and sort of build a stack of training modules into a course or into an arc of training. And I think that's really something that's going to come out in the examples that we share. But with these examples, it's important to remember that these are inspiration. None of these examples is going to be exactly what you require. The idea here is to give you a breadth of different applications and kind of tweak your imagination and hopefully inspire you to go off and build some of your own. So let's take a look at a few. The first one I'm going to share is one of our own examples. This is the Epic Detroit Lab. Heiko, in his job title, is head of the Detroit Lab, but that's not a physical space, right? That's a virtual space that we've built. So this is the lab. You can enter it. It's on a platform called Surreal, so you just enter it through a web browser. It's fully 3D and interactive. You create an avatar. You can go in. You can have meetings. You can have one-on-one. You can have video and audio that comes through. You could pull up a presentation or a video pretty much anywhere and sort of have a seminar or a meeting with a presentation in it. And then you can also import models. So you could put a car in and we can all walk around the car and talk about it. Now, we don't use this specifically for training, but if you talk about easy access points, building rich environments, you could easily add the training scenarios on top of it because you have all the elements there. And I thought this was a really interesting showcase to begin with. And also, have an open invitation to come join us in the Detroit Lab whenever you'd like. Another one of our own examples is the Fortnite March Through Time experience that we did earlier this year. And that was around teaching players about Martin Luther King. And again, it wasn't specifically a training objective. It was an experience. It was to sort of absorb history in more of a museum piece. But you had all the elements of multiple people coming together, going on a path, discovering some things, having information conveyed to them in a really compelling way. And I think it stands up as that game scenarios really do map very, very well to training scenarios. And this is definitely one of the cases where it was a blending of the two. Another one of our examples, for the launch of the HoloLens 2, we did an Apollo 11 experience. It basically allowed you to experience the whole Apollo 11 mission or key points of it from in AR in the HoloLens 2, which was fantastic, and the experience itself was mind-blowing. But what was crucial about this one, the reason why I wanted to highlight it, this is available in our marketplace. We released the code for it. You can go get it. You can experience it on your own HoloLens, but crucially, all the code's there, so you can build any AR training experience on top of this. Again, not training per se, more of a museum piece, but it's the starting point for all of your training. You can build training elements on top of it in AR. When we talk about training, we're largely concerned about humans, but actually the biggest training use case of Unreal Engine is autonomous vehicles. Autonomous vehicles has absolutely exploded over the last couple of years, and there's so many different companies using Unreal Engine in that way. And if you look at things like the way that you need to sort of drive those virtual miles. Again, having that AI for light traffic in there. Typically, the actual driving algorithm is done in off of Unreal. That's on the own tech stack. And then what you do is you bring that algorithm into Unreal to have the background traffic and the scenarios and the visual input that goes in the camera and the sensors. This here is from a university in Barcelona. It's an open source project called Carla. It's a great starting point if you're doing any kind of autonomous vehicle applications. So again, much more core training example here. The team at Inlusion, virtual reality training for aircraft maintenance. They work with a bunch of different airlines and airline aggregation companies, and they do, in this case, training on the Boeing 737, bunch of standard training operations that you might do in person, conveyed to VR, and then sort of disseminated to all the different trainees in different locations. There's a blog on this on our website. In fact, most of these, there's a blog on our website that allows you to get some more information, so I'd encourage you to go have a look at them. Astronaut training and Boeing has been one of the most exciting things that we've been involved in. This is a really great project to use the Varjo HMD VR headset, which is really, really high end. Again, there's actually multiple articles on this on our site and others. And they took the CST Starliner program and did astronaut training, but also training for non-astronauts to help them familiarize with what the program was about. It was really, really successful. The visual quality was absolutely stunning, and it was a great example of really core training principles delivered at a really high end for space, which is great. On a slightly different tack, the team at Abyssal, what they do is they have an Unreal overlay for control of remotely operated submersible vehicles. So typically you have an operator and maybe thousands of miles away in an undersea location, you have an undersea drone and they're controlling them. And what they do is they overlay the Unreal Engine topographical data and other extra information on the camera feed to allow you to operate in dark or dirty environments. What's interesting about this is that you can take the actual live footage and create training scenarios out of it, so the operators can train before they actually get behind the actual vehicle and potentially get into some trouble. It's thousands of miles away, it's undersea, it's hard to get to. You can be really sure that they're well trained. And this is an interesting case where the training and operation basically come out of the same application in Unreal, which is a really core strength of using Unreal for this, is that you can build a training application and an operation application. They're basically the same application, just with slightly different tweaks on the scenarios and a live connection that goes live when you're actually operating. So it's really interesting. And again, I think we have a video on this one as well on our website. So the team at Skyreal work with aerospace companies. They work traditionally in design applications, helping various aerospace companies design aircraft. But what they also can do, and it's primarily a VR product, but what they can also do is they can also set up training around the design. So in this case, this is a design of a fuselage. You can also put it into a factory setting to see what the actual assembly might look like and train the operators there. So it's, again, the way you can just use that one application, the design application in this case, and just really just grow it a little bit, and then you get a training application. That's one of the real powers and flexibilities of using something like a game engine for this. So the last example is a much more down the line training example. The team at Applied Research Associates, particularly Virtual Heroes, just have built a generalized training platform in Unreal. I have a defense example here, but there's civilian, there's manufacturing, there's health, medical. All these different scenarios are available off of a common training platform. They have invested the tools into building the core elements of training as an Unreal application. And then again, with that level creation aspect that I talked about earlier, iterating really, really quickly and creating training scenarios for all the endpoints their customers might desire. So we're back to SpongeBob, and what is the point of all this? Again, the point of this is inspiration. Hopefully you see some bits and pieces there that you can assemble and you can kind of remix into your own best training idea. I hope that inspires you to do something like that. But what do you do when you get inspired? So the best thing you can possibly do is reach out. Every one of the projects that you've seen here in this deck started out as a crazy idea someone had, and they reached out to somebody at Epic and said, can I do this? And the answer is invariably yes, and how can we help? We are a very open and accessible team. We love to talk about your projects and give the projects as much help as we possibly can. Nothing inspires us more than to see you guys do awesome things with Unreal. And if you have any kind of inkling that you want to do something in training, again, the best thing I can do is have an open invitation for you to reach out. And that brings me to the end of my slides. Thanks very much for the opportunity to present today, and have a great day.